Several observations clearly indicate that the mass balance has been lost.
Yeah, we are ready.
Every year, the Greenland ice sheet is becoming smaller. The loss of mass, especially from ice discharge, exceeds the amount of snow that Greenland ice sheet receives every year, and the trend is increasing. We're simply losing more and more ice every year.
Scientist Mark Fainenstock has developed a method to measure the speed of the ice near the ocean in order to understand how the ice is able to accelerate so massively.
We run time-lapse cameras. We run these cameras in these metal boxes here to allow us to see what the glacier does when we're not able to be here. We have learned from these cameras that there is this interaction, this shutdown of calving and this re-advance of the glacier. And we really don't understand yet why the breaking off of icebergs starts in the spring, but before melt really starts. And we think that it's the interaction between the ocean and the ice that destabilizes the ends of these glaciers and allows them to speed up. So we think by following with cameras this annual cycle, we can get a better picture of how the ocean and the ice interact with each other. And that gives us a clue as to why the glaciers are so responsive to warming. We think that the changes can be pretty subtle changes in the fjord, and that can lead to very large changes like the ones we've observed here.
Many of the big glaciers in the southern part of Greenland are acting like this one, the world's most active glacier located in Ilulissat. Data from GIAS has showed a marked ice retreat during the last 100 years, and during the last decade, the amount of ice leaving Greenland as icebergs has grown over 30%, from 330 gigaton to 430 gigaton. As a consequence of these rapid changes, we need to understand how much faster the ice can flow.
We also need to understand how rapidly a change at the coast can reach into the ice sheet. How much ice in that ice sheet and will end up out here in the fjord, and how quickly that can happen. One of the things that happens is that as a big glacier like this draws ice out of the ice sheet and the surface lowers, that puts the surface of the ice sheet down in a warmer climate, and which increases the amount of melting that you experience on the ice sheet at a given location.
Increased melting and its consequences for the speed of the ice loss is an important feedback mechanism researchers are now studying. The objective is to be able to map how much the temperature can rise before we see an even stronger acceleration of the ice flows. The increased amount of surface melting is caused by the sun, and during the last 50 years, the temperature over the ice sheet has risen more than 2 degrees Celsius, causing the surface to melt. When the air and the sun heat the upper layers of snow and ice, massive ponds of water and roughing rivers are formed. The ponds and the rivers disappear into so-called moulins, huge holes and caves formed in the ice. The moulins are believed to lead the water to the bedrock, creating a linked process, another feedback mechanism, that helps the ice dynamics go even faster. Researcher Konrad Steffen has been working with the ice, trying to understand the linked processes.
Now what we observe here is that the water that goes into the ice actually can lubricate the underside of the ice sheet, where there is bedrock, reduce the friction, and the moulins is actually the conduit that makes ice move faster towards the coast. Here where we are right now, on the Greenland ice sheet, the ice moves 33 centimeters per day towards the coast and activates also these outlet glaciers that are going into the fjord. And that has been what we call a dynamic effect of the warming.
For a long time it has been believed that the melting processes and the moulins have been responsible for the acceleration of the ice and the discharge of icebergs into the sea. But recent research has indicated that the heating of the ocean and the ocean currents are beginning to play a major part in the acceleration of ice discharge.
We had a small anomaly of about 1 degree in the ocean water over a period of about 6 to 7 years. And that was enough to actually penetrate all the way north into these fjords, melt ice from underneath, and then the ice was moving faster. That's another mechanism to actually get ice into the ocean faster by small changes in ocean current, ocean temperature.
Satellite measurement is the strongest instrument for showing the total picture of the melting of the ice and ice discharge pattern. Satellites measure all of the ice sheet, and the results support the other data collected by various measurements along the coast. The melting processes and ice discharge are accelerating and working their way to the north of Greenland.
Most glaciers that were steadily flowing down and then in the ocean are completely pulled apart. They are actually moving much faster, and this region, what we know is happening around Jakobshavn, is now progressing further north, and it goes on both sides of the coast.
When we add all measurements together, they all point in the same direction. The results show us that the inland ice is losing approximately 160 gigatons of ice per year, or enough to cover all of Denmark with nearly 4 meters of water.
We have to concentrate our research on the processes occurring here to understand why is the ice moving faster, when does it reach the northern part of Greenland, and how do we feed it back into our model to make a prediction for the future sea level rise. It has large consequences of the future of sea level rise and society around Greenland.
You can give a talk about the changing Arctic now and only show examples. You don't have to talk in generalities. You don't have to talk about theories. You can just say, look at the sea ice, look at the changing landscape, look at the changing glaciers. This is what a warming planet looks like.
But what future does a warming planet hold for the people of the Arctic? Our fishermen, what is their challenge?
Greenland, the retreat of ice is changing the possibilities for mining, for sea transport, and for energy production in and around Greenland. And it could also mean that Greenland becomes much more centrally located on the planet because its transport between Europe, America, and Asia can come across the Arctic Ocean. So Greenland has to find this very delicate balance between, on the one hand, being able to exploit its mineral and natural riches, and on the other hand, not being exploited itself and not destroying Greenland nature or lose the cultural identity of Greenland.
We have observed that the ice is melting, the oceans are rising, and the Arctic is warming. Facts that hold a challenge for all of us.
It is the generation of today that have to define the outcome of the future of this planet tomorrow. We have to act now, soon, to make changes that the climate is not warming in future decades and centuries.